Today we're going to uncover, I think, some really, really surprising facts, and it wasn't just stumbled upon, was it?
No, not at all.
The discovery of Neptune is this, tale of intrigue and math and even, a little bit of competition, right?
Yeah, it really is. It all started with Uranus.
Okay.
Astronomers noticed that its orbit, it wasn't quite following the rules. It was kind of wobbling in a way that suggested some unseen force was tugging at it.
Oh, so they were like, okay, something's off here. There's a hidden culprit.
Exactly like any good mystery.
Yeah.
Two mathematicians, Urbain Le Verrier and John Couch Adams, independently calculated where this mystery planet should be.
Wow.
Based on Uranus's orbital wobbles.
So they were like cosmic detectives.
Yeah, exactly like a cosmic detective story.
I love that.
And you know what the craziest part is? They were both right.
They were both right.
To predict a planet's existence and location based on math alone.
That's incredible.
That's remarkable.
Yeah.
Both Le Verrier and Adams deserve credit for their incredible work.
Absolutely.
Although there was a bit of a debate at the time about who should get the ultimate recognition. But there's another twist.
Okay.
Galileo. Galileo
Yeah.
almost spotted Neptune over 200 years earlier.
Oh, you're kidding. Hold on. So Neptune could have been discovered way back in the 1600s?
Yeah.
What happened?
He actually marked it in his drawings.
Wow.
But he mistook it for a fixed star. His telescope just wasn't powerful enough to reveal that it was a planet.
Right.
Even today, observing Neptune is challenging. It's so far away, it appears it's just a small blue dot.
Yeah.
Even through our most powerful telescopes.
It's true. And speaking of which, it is an ice giant, right? Not a gas giant like Jupiter or Saturn.
Yeah, that's a crucial distinction.
Yeah.
Ice giants, like Neptune, are smaller. And they have a higher proportion of heavier elements that would form ices at those extremely cold temperatures.
So like water and methane ammonia?
Exactly.
But it's not a giant ice cube, though, is it?
Definitely not. Neptune's internal structure is far more complex and fascinating than a simple ball of ice.
Yeah.
Imagine like a water ammonia ocean, deep within the planet's mantle under immense pressure.
Oh, wow. Yeah, and I was reading on Wikipedia that there might even be diamond rain.
That's right.
Oh, gee.
That's right. And what's fascinating about this diamond rain is that it could help explain Neptune's internal heat.
Okay.
Imagine the energy released as carbon atoms are squeezed into diamonds under the extreme pressures deep within the planet.
Okay, that is mind-blowing.
Yeah.
But can we talk about that stunning blue color?
Yeah.
What makes it so much bluer than Uranus?
So Neptune's atmosphere is much more dynamic and stormy than Uranus's, and this activity, along with the presence of a hazy lower stratosphere, contributes to its deeper, richer blue hue.
So it's not just the methane, it's this combination of the atmosphere's composition and wild weather patterns
Exactly.
that create that vivid blue.
Yeah, it's like comparing a calm, hazy day on Uranus to a stormy, electric blue day on Neptune.
I love that analogy. And speaking of weather, Neptune is home to the most ferocious winds in the solar system.
That's incredible, isn't it?
I was reading they can reach supersonic speeds.
Yeah.
Over 1,300 miles per hour.
That's insane.
That's insane. What would it be like to even experience winds like that?
It's hard to even imagine. These incredible speeds dwarf anything we experience on Earth.
Right.
And they're responsible for some of Neptune's most distinctive features, like the Great Dark Spot.
Okay, the Great Dark Spot, now that's that massive swirling storm that Voyager 2 saw in 1989, right?
That's right.
But wait a minute, didn't it disappear a few years later?
It did.
Oof, just gone.
Yes, the Great Dark Spot vanished, which baffled scientists.
Yeah.
It was later replaced by other dark spots.
Oh, okay.
But they tend to form and disappear much faster than we'd expect for a planet so far from the sun.
So we've got these disappearing storms. What about that speedy cloud group called the Scooter?
Ah, the Scooter.
Yeah, how can something move that fast in such a cold, distant environment?
Well, this is where the mystery of Neptune's internal heat comes in.
Okay.
Unlike Uranus, Neptune radiates more energy than it receives from the sun.
So it's got its own internal furnace?
Yeah, it's like it has its own internal furnace.
But where's that heat coming from?
That is the million-dollar question.
Yeah.
The source of this internal heat is still a mystery.
Right.
But it's clearly a major factor in driving Neptune's incredibly dynamic weather patterns.
Right. And here's another twist that's been puzzling scientists. Recent research shows that Neptune is actually cooling down.
Yeah.
Cooling down.
Yeah.
But it's summer in Neptune's southern hemisphere. Shouldn't it be getting warmer?
You'd think so, right?
Yeah.
Scientists expected to see a gradual warming trend as the southern hemisphere receives more sunlight.
Yeah.
But instead, Observations over the past 2 decades show an overall cooling of Neptune's atmosphere.
So it's getting colder when it should be getting warmer.
It seems counterintuitive, doesn't it?
What's the explanation for this?
Well, there are a few possibilities.
Okay.
One idea is that changes in Neptune's atmospheric chemistry might be influencing how effectively the atmosphere radiates heat.
Okay, so the increased sunlight could be triggering chemical reactions
Exactly.
that are affecting how the atmosphere traps or releases heat.
Exactly.
So it's like Neptune is running a giant planet-sized chemistry experiment.
That's a great way to put it. Yeah,
Hmm.
and it highlights how interconnected atmospheric processes are.
Yeah.
Even subtle changes in composition can have significant effects on temperature and climate.
But what about those random weather variations we talked about earlier?
Right.
Could they also be playing a role?
Absolutely.
Yeah.
Neptune's atmosphere is incredibly dynamic. It's possible that those fluctuations are masking any long-term warming trend, making it harder to see the bigger picture.
It's like trying to hear a whisper in the middle of a hurricane.
Exactly.
You know, the noise just makes it hard to pick out the signal you're looking for.
Exactly.
Right.
We need more data and a better understanding of Neptune's atmospheric dynamics to really disentangle what's going on.
Okay, so we've got this cooling atmosphere as one big mystery.
Yes.
But let's not forget about the other elephant in the room.
Right.
Neptune's internal heat.
Yeah.
Where is all that extra energy coming from?
That's a question that has baffled planetary scientists for decades.
Yeah.
Neptune radiates much more energy than it receives from the sun, meaning there has to be an internal heat source.
But it's too small and too far from the sun to have held on to its primordial heat.
That's right.
You know, that leftover energy from its formation.
Right.
So what's the explanation?
Well, there are a few leading theories,
Okay.
but none are definitive yet. One possibility is the decay of radioactive elements in Neptune's core.
So it's like Neptune has a slow-burning nuclear reactor deep inside.
Yeah, in a way, yes.
Wow.
Another possibility is that gravitational contraction is generating the heat.
Okay.
As the planet slowly shrinks under its own gravity, the compression releases energy.
So Neptune is either slowly undergoing nuclear fission or it's gradually squeezing itself tighter.
It's one or the other.
Either way, it sounds like a long, drawn-out process.
It is a long and drawn-out process, and the amount of heat generated depends on the composition and structure of Neptune's interior, which we still don't fully understand.
Right. It's like trying to figure out what's making a ticking sound in a clock versus being able to open it up and look inside.
That's a good analogy.
Yeah.
But new tools like the James Webb Space Telescope are helping us get a clearer picture.
Oh, how so?
Well, Webb's powerful infrared vision allows us to probe deeper into Neptune's atmosphere.
Okay.
We can measure its temperature, its composition, and even wind speeds with incredible precision.
It's like having a cosmic stethoscope
It is.
that lets us listen to Neptune's heartbeat
Yeah.
and maybe even diagnose its internal heat problem.
Exactly. By combining Webb's observations with theoretical models and computer simulations, we're getting closer to understanding what makes Neptune tick.
Okay, so we've talked about the cooling atmosphere,
Yeah.
the internal heat puzzle.
Right.
What other mysteries are keeping Neptune researchers up at night?
Well, those clumpy rings are still a bit of a puzzle.
Yeah, why are they so uneven with those distinct arcs and gaps?
Right. Well, Galatea's gravitational influence plays a role.
Right.
But it's not the whole story.
So what else might be contributing to this clumpy ring structure?
Well, the ring particles themselves can interact gravitationally, leading to clumping.
Uh-huh.
And the constant bombardment by micrometeoroids and radiation can disrupt the rings,
Right.
carving out gaps and creating those arcs.
So it's like this constant dance of gravity and collisions and even the sun's influence shaping those rings.
Exactly. Disentangling these factors and understanding how they contribute to the observed ring structure is an ongoing challenge.
Speaking of challenges, let's talk about Triton again.
Of
We know it was likely captured from the Kuiper Belt.
Right.
But how did that impact Neptune's original moons?
Triton's arrival probably caused major disruption to Neptune's early moon system.
Oh, wow.
Imagine the gravitational chaos as this massive moon entered the scene.
It's like a cosmic bull in a china shop.
Exactly. The gravitational interactions likely ejected some moons through others into chaotic orbits and maybe even triggered collisions.
Wow. So Triton's arrival was like a defining moment for Neptune's moon family.
It was. And the evidence of this disruption is still visible today
Oh, wow.
in the irregular orbits of some of Neptune's smaller moons.
It makes you wonder about all the stories etched into those moon stories of ancient cosmic encounters.
They're silent witnesses to the dramatic events that shape the solar system we see today.
This has been an incredible journey. We've explored some of Neptune's biggest mysteries, from its cooling atmosphere and internal heat to its clumpy rings and the dramatic arrival of Triton.
It's been a fascinating deep dive, and it's incredible how much we've been able to learn about such a distant world.
So we've covered a lot of ground in this first part of our Neptune deep dive.
We have.
We've explored its dramatic discovery, its wild and unpredictable atmosphere, its captured moon Triton, and its delicate decaying rings.
Yeah, and we've only scratched the surface.
That's right. In the next part, we'll take a closer look at those mesmerizing rings and delve into the mysteries surrounding Neptune's many other moons.